All right, so it says, which statement is true about the end behavior of the logarithmic function f of x equals log of the quantity x plus 3 minus 2. So there's a couple things. If it's inside the parentheses, it's the opposite. So this is going to shift this to the left 3 units. And the 3 is, because it's inside the parentheses. This one is going to shift it down 2 units. So this is the regular log function that's been transformed. But to verify the end behavior, I'm just going to plug it into a calculator. So what I mean by that is I have my original log function plugged in. And, oh, hey, look, there's one. It's already in there. Let me plus or minus 2, I'm sorry. So as I look at the graph, there's the original log function crossing the x-axis at positive 1. And then this is the transformed. But I'm gonna have to scroll out to a standard zoom because to answer the question, we need to see both graphs. So the blue graph is the parent function log of x, and then the yellow one is the transform function f of x that we have listed here in the problem. What I want you to see, and it's kind of hard because your graphing calculator has a hard time with the vertical asymptotes graphing it, but really what's going on here, let me zoom out here. The yellow graph and the blue graph has a vertical asymptote at 0. So this will continue to go down, but it'll never ever at x equals 0. It'll never ever cross the y-axis. Now, f of x, the function that we have listed here, is never going to cross this line. In other words, this goes on forever like this. So what does that mean? Well, what it means is that as x decreases, y moves towards the vertical asymptote x equals negative 3. In other words, x equals negative 3 is an asymptote right here at negative 3 that yellow line gets really close to, but it never crosses. That's the vertical asymptote. Okay? So that is the answer. I don't know if I'm modeling proper test-taking protocols, right? You're supposed to bubble in inside the circle and not go outside, but it's kind of hard. Anyways, that's the correct answer.